Again, I'm just finishing my notes here, and I didn't want to rush through anything. And I believe this book does not like having imaginary or complex numbers in the denominator. So how do we fix it is very similar to the way we fixed irrational numbers in the denominator, where you do the conjugate. Well, the conjugate, you keep the real part the same, and you change the sign of the imaginary. If you do that in the denominator, you also have to multiply that into the numerator. The reason why this works is because the imaginary parts all go away. So as you FOIL the denominator, 3 times 3 is 9. The outside is negative 3i. The inside is positive 3i. And I times negative I is negative I squared. So as you combine like terms, the i's go away. And remember, I squared equals negative 1. So it's 9 minus negative 1, or 9 plus 1 will give you 10. Now in the numerator you have a little bit more work to do. You do have to FOIL 4 times 3 minus 4i, minus 3i, and negative I times negative I is a positive I squared. And remember, I squared is negative 1, so 12 plus negative 1 would give me 11 minus 7i. Assuming I did everything correctly, that would be your answer to that problem. Looking at the next one, not trying to make this or oversimplify it, but what I would do is just multiply top and bottom by I. You don't have to worry about that 2. So in the numerator you just get 5i, and in the denominator you get 2i squared, but I squared is negative 1, so 2 times negative 1 will give you negative 2. That's it. Now remember, I talked about this one in the first video, and I gave you this really weird statement that what I was actually doing is giving you the complex plane, where this is the real part, and up here is the imaginary part. And the squared is how many, the exponent is how many quarter rotations you do. So if we start with I to the 0 power on the positive x-axis, that's on the real number line to the right 1. So if I do I to the first power, it's up on the imaginary axis, positive 1i. And if I do I squared, that's over here, it's on the real axis at negative 1. And then I cubed is on the imaginary axis, which is negative I, because it's down 1 imaginary unit, and then I to the 4th. So the reason why I shared this with you in the first video is to get you to really understand that you could just count all the way around. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So I to the 9th power is equal to I. Now, this is not the only way to do the problem. I just think a nice visual helps students. The whole premise, though, is that you can subtract 4 from each exponent. So I to the 9th is equal to I to the 5th, which is equal to I to the 1st. So you have 2 options of doing this answer. So let's see, I to the 9th got us up here. So let's do I to the 16th, 10, 11, 12, 13, 14, 15, 16. This answer should be to the 1st power. And what you'll probably notice is every multiple of 4 ends up over here. Every multiple of 4, 4, 8, 12, 16, 20, 24, 28, 32, 33, 34. So this answer is equal to negative 1. Again, there's so many different ways of doing this. I don't want to just tell you to do one. Now, I to the negative 24th power, you can think of it as just going the opposite way of going this way. But it ends up just being positive 1 again. I'll let you kind of work through that and see what works for you. So hopefully I did a good enough job explaining that, and you can see that rushing through this last one in the first video would have been a bad idea. So you are now ready to go forth and finish your homework after after watching this video.